All right, class. So in part one of lesson 10.2, you looked at how to simplify radicals. Okay, so the way that we did that, of course, looking at step one here, these are our three steps that we talked about in the process of, or three basically qualifications that it has to meet in order to make sure that your radical is in standard is in simplest form. So for step number one, okay, we have no radicands that have perfect square factors other than 1. So we looked at how to eliminate those perfect square factors, whether they be numbers or whether they're variables. And so we looked at the process of simplifying those. So now we're going to look at basically is number 2 here. No radicands contain fractions. Okay. So for example, what that means is this. If I have this example here, we have square root of 35 over 15. Well, here we have a fraction, of course, and that fraction is underneath the radical sign. So what I want to do, I want to simplify this because, as it says in number 2, no radicands can contain fractions. So, of course, we have a fraction. So how do I eliminate that fraction? Well, actually in step number 1 of this one, I noticed that 35 over 15, I can actually simplify that. So to simplify 35 over 15, I would divide by 5. Okay, dividing by 5, I end up with 7 over 3. But I still have the issue of I've got a fraction underneath the radical sign. Okay, so very simply, what I would do, I'm going to rewrite this as the square root of 7 over the square root of 3. Okay, so now that I have the square root of 7 over the square root of 3, I can fairly simply eliminate that radical in the denominator, because we also know that we can't have radicals, as it says here, no radicals in the denominator of a fraction. But in order to eliminate that, very simply, all I do is I'm going to take whatever my denominator is, okay, in this case, which is square root of 3, and I'm going to multiply that times the square root of 3 over the square root of 3. Okay, so whatever I multiply by in the denominator, I have to multiply by the same thing in the numerator. Now, why am I doing that? Well, remember what our objective is here. We need to eliminate that radical in the denominator. Okay, we can't have that there. So in order to do that, well, if I do the square root of 3 times square root of 3, of course, that is going to be square root of 9. So anytime you multiply by the same number or by the same radical, you're going to end up with a perfect square. So we know that if we have a perfect square, now we can simplify and eliminate that radical. Well, up top, I'm going to do square root of 7 times square root of 3, which is square root of 21. So now I got the square root of 21 over square root of 9. We simplify that. That is equal to 3. Now that is in simplest form. Let's look at all three phases here. Okay, for number 1, no radicands have perfect square factors other than 1. Okay, we look at the number 21, square root of 21. Okay, that is, okay, we have no perfect square factors. We have 7 and 3, 1 and 21. So we're good there. Now let's look at do we have a fraction underneath all the radicals like we have here in the beginning? No, we don't. Okay, we just have that whole number here in the numerator, but then also we have the whole number radical here, but then we have a whole number in the denominator. So we have eliminated that radical on 3. No radicals appear in the denominator, so we don't have a radical in the denominator. So this actually is in simplest form. It passes all three tests. Okay? All right, so let's take a look at another example. Okay, excuse me. So what we're going to do here, we have the square root of 6y over square root of 12. So once again, thinking through those three qualifications that it has to pass, can't have a fraction underneath the radical sign, okay, which we actually don't here. Okay, we've got a whole number on both the top and the bottom. But the problem that we have, actually a couple of problems here, but the problem that we have is we have a radical in the denominator. Okay, so we have to eliminate that. Now, one thing, once again, that I can actually do here is I can simplify this. So it makes it a little bit easier, but I can simplify this. I got 6 over 12. So I can simplify by dividing by 6. It's a common factor. Now it makes it really easy to work with. So we got square root of y over square root of 2. So now in order to eliminate that radical in the denominator, once again, it's going to multiply by whatever is in the denominator. Whatever I do on the bottom, I have to do on the top. Okay, that's our rule for any fraction. So then we're going to multiply 2 times y, we get the square root of 2y. 2 times 2 is square root of 4, which will simplify to 2. So that would be in simplest form. Okay, let's check. Here we have no perfect square factors underneath the radical sign, so we're good there. No fractions underneath the radical sign. And then we have no radicals in the denominator. So once again, that is in simplest form. Okay? Okay, so this takes us to something called conjugates. Okay, or not conjugators, conjugates. So with conjugates, okay, what we have in this case, we have a fraction. It does have a radical in the denominator, but it's also being added to a number. So we have 3 over 5 plus square root of 2. So now it gets a little bit trickier because we've got that it's being added to a number. Okay, that radical is being added to a number. So once again, it's still the same three things here. We've got to make sure that it's in simplest form. So here, since we do have that radical in the denominator, we have to simplify this. So how are we going to remove that radical? That's our issue here. Okay, that's our objective, is to remove that radical from the denominator. Okay. Well, very simply, in order to do this, what you're going to do is you're going to multiply. Okay, this is your conjugate by 5. In this case, multiply by 5 minus square root of 2. Okay. Now, the reason that we do that, if you remember, back when we dealt with the difference of squares, okay, whenever we multiplied with differences of squares, okay, we had basically the same expression but different signs, right? So if I had like x plus 2, the opposite of that would be x minus 2. Okay, when we multiply those two together, what ended up happening? We eliminated that middle term. Okay, so in this case, it's going to be the same thing. We're going to end up eliminating that middle term. But then also, as we looked on the two previous problems, whenever we end up multiplying these two together, well, what's going to happen? We're going to eliminate that radical. Okay, so but just like on the two previous problems, whatever I do on the bottom, I've got to do on the top. Okay? Alright, so I'm multiplying here. So let's just start with the numerator. When I multiply the numerator, I'm going to actually end up distributing. Okay, on that. Now, when I multiply on the bottom, well, just like a difference of squares, okay, I'm multiplying two binomials. Okay? But remember, what happened when we multiplied with a difference of squares? We always eliminated that middle term. So same thing here. But let's start with the numerator. Okay, the numerator, I'm going to start here. And once again, I am distributing this 3. So when I distribute that 3, I'm going to distribute to both terms. So then I get 3 times 5, we get 15. 3 times square root of 2, it's going to be minus 3 and the square root of 2. Then in the denominator, okay, I'm going to be foiling that. But once again, since we're eliminating the middle term anyway, I can just multiply 5 times 5, I get 25. And then square root of 2 times square root of 2 is square root of 4, but we know, of course, square root of 4 is, and that's going to be minus 2. Okay, why is that minus? Because we're multiplying a positive square root of 2 times negative square root of 2. Okay? Alright, so then we're going to end up with 15 minus 3 and the square root of 2 over 25 minus 2 is 23. Okay, and that is in simplest form. Okay, we look here, we have no radicals in the denominator. We have no fractions underneath the radical sign. And we look underneath the radical sign, also we see that there are no perfect square factors. So that is in simplest form. Now, another thing you also need to check these three terms. 1, 2, 3, those three right there. And see if you can simplify there, because sometimes you can actually do that. So for example, what I mean by that, if this was 15, okay, which it is, but if this were like 5 and this was 25, then I could simplify by dividing by 5. Okay, so just be careful with that too. There are times you can simplify those. Okay, all right. So let's do one more of these, and this time I have 7 over 3 minus square root of 7. Now, also, if you just want to pause the video and try it, that'd probably be a good idea. Just give it a try. But I'm going to continue on and go through this problem. But you can pause it here and give it a try yourself, and then come back and check it. Okay? All right, so once again, since we're dealing with a conjugate here, okay, I know that because I have an expression here, 3 minus square root of 7. Okay, I can't have that radical here in the denominator, so I need to eliminate that. So like on the previous problem, I'm going to multiply. But this time, since it's 3 minus square root of 7, I'm going to multiply by 3 plus square root of 7. Okay, now, just like on the previous problem, I'm going to take that number 7 and I'm going to multiply by that binomial. Then on the bottom, 3 minus square root of 7 times 3 plus square root of 7. Okay, all right, so distribute in the numerator, so we get 21 plus 7 in the square root of 7. Then in the denominator, I'll get 9. Remember, we are eliminating the middle term. And then multiply negative square root of 7 times square root of 7. Of course, it's square root of 49. So minus square root of 49, which would be 7. Okay, all right, so then I'm going to subtract. So I end up with 21 plus 7 and the square root of 7 over 2. All right, so let's just check. Okay, no radicals in the denominator. That's good. No fractions underneath the radical sign. That's good. And also no perfect square factors underneath the radical. So that's good. That is in simplest form. Passes all 3 tests. Okay, y'all. So that is all there is to it on the second part of Lesson 10-2. And I'm sure you guys will do a great job.